Hey, good morning, ladies and gentlemen, and welcome to Construmat's Knowledge and Experience series. This is Volume 3, Number 3, and I'm Mami Adra, your moderator. It's my pleasure to introduce our distinguished speaker, Mr. Kwasi Nyarko Poku-Agyemang. Currently a research assistant at INATECH in Germany, Kwasi specializes in mobile sensing and robotics, with expertise in sensor fusion and 3D point cloud reconstruction. He's actively shaping the future of technology, particularly in virtual and augmented reality for monitoring large structures. As a seasoned expert in geospatial analysis and robotics, Kwasi enlightens us on augmented reality and virtual reality, revolutionizing the way infrastructure projects are designed and visualized. Please join me in welcoming Mr. Kwasi Nyarko Poku-Agyemang. Kwasi, good morning.
Well, can you hear me, everyone?
Right. So I believe we can dive into your session right away. You'll be able to share your screen so that we begin. Yes.
I share my presentation quickly and can you see my screen?
Yes, we can.
Okay, so I guess everyone has have a brief introduction of what I do, but today we're going to focus on the area of augmented reality and virtual reality, looking at how we can adapt it into our industry or the industry you operate. And I believe most of us here into the civil engineering or just spatial space. So we're going to look at how we can take advantage of the technologies and like first understanding it and how to use it in our daily applications or the potentials of how we can adapt such a technology into our pipeline when we working or when we're doing any other form of projects or interacting with the technology in our space. So we'll first try and look at the definition of what the technology is and what's the backbone of the entire technology, and we can also look closely to how it's changed over time and various applications. So I'll start with virtual reality. Am I very audible for everyone? Can everybody hear me?
Yes, you are. We
Is
can
it
hear
audible?
you.
Okay. All right. Perfect. So virtual reality is a long-standing concept that's been around for ages. The main focus or the main technology or the idea behind it is basically reorienting the user's interference with the computer, simulating the real world so they can interact with the world with your sensory systems. So it takes advantage of all the sensory systems we have as individuals. So from visual to audio to tactile to smell to taste, we can orient ourselves in an environment where you can remodify these senses virtually. So simulating something that doesn't exist in the present environment to make the person feel or think or perceive the environment that doesn't exist around them. And so it's highly reliant on your sensory system. I think basically every human being makes sense of the environment using their senses. So the ability to make use of the information we're sharing now is because you hear my voice, you see my screen, and you can participate in this environment because of your sensory. So if I'm able to modify your vision and modify your hearing to suit a specific environment, then I'm creating a different reality in which you participate. So that's the whole concept, changing your visual, your audio, your tactile, your smell, and your taste senses to be able to naturally take you to a different environment is what we call as virtual reality. But to be able to do that, we need to first have a computer that interface with these sensor systems to be able to transport you from your real reality, so your present reality, to a virtual space. So the idea of virtual comes from the fact that it's not realistic. So we're creating an elusive reality in which you participate in using these sensor systems. Okay. So it's been around the block for a while. So it's not a new phenomenon, as I said. I think in the first scientists who discovered this realized that if you put two photographs next to each other and you visualize it by the individual eye sensors, the eye balls, you can create a 3D object in space that didn't exist before your eye. So he puts two images next to each other, tilt them at 45-degree angle, and you're able to perceive a different object in your vision. And it was highly beneficial. That's what led to the concept of stereo vision. So um, the technology evolved from 1838. So it's not a new phenomenon. It's just a bit louder lately because of the technology of catch up to with the hardware. So the main problem back in the days was the sensor systems. I think I can use my mouse so that I can point out stuff. Um, So with this one was the second edition after approximately 100 years, so let's say 80 years afterwards. There was a photographer, a cinematographer who was able to simulate a movie in a huge box where four people could participate. So you closer from the world, you're sitting in a booth with a virtual environment played and you participated. And so it was so huge of a technology that it couldn't be moved around. So just four people could participate at a time. And within the booth, he tried to simulate smell and audio and also visual to make the person re-immerse themselves in a different environment. And from there, people got interested in it because if it gave it gave a new understanding of how humans make a sense of the environment and how we can modify our environment to make people relive certain experiences or like reshape how they perceive the environment. And I think in 1968, there was another scientist who tries to take it a step forward from the booth, so the huge system to a head one system. So we move from it being stationary to something we can put on our head. So in this case, we try to reduce the technology to something that's wearable. So that's where the idea of wearing the technology came from to make it more flexible. Although during the whole process, it has to be connected to a central processing unit where you can get the image fed to the user. So during the time it was a very revolutionary because most of the technology that exists prior to this one was a stationary booth where the user had to physically image yourself. But with this, they had one computer. It made it a bit easy for people to just switch users easily. So you just put a HMD on your head and you move around the space. And in 1985, there was another group of people who introduced the glove concept, where you're not just interacting with the glasses, which is one on your face, but they also added some gloves where you can physically make sense by feeling with your fingers what's in the environment, in the virtual environment. So it gives you a sense of touch, not just in the real environment, but also in the virtual environment. And this was like another evolution of the whole idea. And in 1989, NASA got involved. So NASA started training their astronauts of how the space environment looked like with a whole new and newly enhanced technology. I mean, when NASA gets involved, there's more money pumped into it, so it gets more refined and more detailed because of the amount of pool that NASA has. So in between 1989 till 2019, most of these things were not commercial. Most of the things were done in research groups, and high-end production was just focused on the industrial applications. In 2019, we got the first commercial off-the-shelf um, virtual reality hardware that anyone could purchase and have a feel of how these things work. And quite recently, the big tech giants joined the game. So we have Apple coming into the space where they're creating the Apple Pro Vision, and it makes it more interesting because now it's making it more accessible and more easy to use by most people. But all this technology stems from someone trying to make you visualize images that didn't exist in your vision or in your real world in 1838. So it's been around the block for almost 200 years, and we have not really maximized the potential as you'll see in the um, subsequent slides. So we have to take advantage of something that has been refined over time. And the truth is, over the time, it got a bit cheaper, which I probably will talk about in details in the subsequent slides as well. So when we talk about virtual reality, we have like a number of applications we can off our head think about. I think the most predominant one is entertainment, so like gaming, for example. There are a lot of first-person games where you see people or videos of people wearing these glasses and participating in a video game. I think it's very common in our space and in most game centers. I don't know about whether there's. I think there should be somewhere in Accra, somewhere where you can go and participate in virtual reality games, video games, and most recently, like most of the Formula One and the racing games have created a VR application where you can wear these things and have a real feeling because it simulates the environment or the reality of you being in a racing car. It's more interactive to the human brain. You perceive yourself as a Formula One driver, for example. And for rare sports like skiing and diving, which is something that I don't think it's I call it white people sports. It's not very friendly to most of us. So we can only participate by immersing ourselves in a virtual space because of the level of anxiety most people get when they are diving. I mean, nobody's going to jump out of a plane. And we know more people, so we don't do stuff like this. So we can only experience some of these things by just being in a virtual environment. It gives you a similar feeling of how these things operate. And it's entertainment, especially cinematography, it's changed the way we perceive movies and even music, listen to music. So in entertainment, you have like VR cinemas where you go and you sitting in the middle of the action. So you see the cars driving past you in the middle of the street. You interact with the cast, with the people, and it's very immersive. It gives you a feeling that you were present while the movie was being shot, and it changes the way you interact with the movies. I think quite recently I saw I don't know, a very popular um Hollywood producer, Michael Bay. He does these explosive movies. I saw a video of someone getting so immersed they felt a part of the whole explosion and they jumped out of their seats. That's how immersed you can be when you're in such a virtual environment. And I think in the health sector, it changed so much of what we can do. Doctors over the years were doing a lot of try and error because they have little or no knowledge about the patient. But with virtual reality can actually simulate everything with regards to surgery, diagnosis in a virtual world, practice it countless of times before you go to do the surgery. So with health, it really improve the outcome of surgery, of like diagnosis, and it changes how humans or doctors approach diseases and complex surgical operations. And in their training as well, you risk using someone's life as a lab rat. So most of the time they use these simulated environments to learn about vital intersection, the health intersection. So for example, a CPR can be given to a dummy in virtual world more in a more realistic way than practicing and then someone who's actually dying. So give them more room to practice some of their trade in an non-existent world, more or less, so they minimize their errors in the real world. There are countless of applications, but I think with socialization, it became more interesting when Facebook joined the game. So this is Facebook's Quest environment, or they call it the metaverse. So you put on your virtual glass, you go into this utopic world. So it's not very realistic, it's very utopic. You meet friends, you socialize with people all around the world. I think the internet was already doing that, but the only drawback was you couldn't feel the presence of the other people. With the virtual reality, it gives you a full sense of being in this utopic space with people all around the globe. So it's really nice. And currently too, they are creating more and more games to make people just socialize. I think Fortnite, one of the popular games, created a room where people can just come and just sit around and chill, just to socialize. I think during the pandemic, we all saw the impact of non-contact interaction with people and how we can really change the way we see the world. So VR can give us all these possibilities, and there are countless of them. So far, I've just mentioned a few, and we're going to look at the engineering applications as well. So we're going to the brother or the sister of virtual reality. So virtual reality, as I said, is creating a new environment where you get yourself immersed by manipulating your senses to make you feel in a different space. Where augmented reality or extended reality or mixed reality, they are all synonyms. It tries to blend the actual environment, like the real world and the virtual world. So by definition, this interaction of the real world and the computerly created environment by also manipulating the same sensory systems. But in this particular case, it's a combination of the two things. So with virtual reality, you're dissociated from your world, but with augmented reality, it's the mixture of the real world, augmenting or like projecting a virtual world onto the real world. And with this one, there are different ways to do it because in the virtual world, you're just relying on to see by just wearing the hardware to cover your eyes, so your eyes are fully enclosed from your environment. But with the virtual reality, you have the world at the background or the foreground, and you can project stuff onto it. So in the image we see here, we can use the camera of our mobile phones or tablets to have a good feed of things that existed before we even came into the world. For example, the tooth of a canine that existed in the dinosaur world. We can have a look at it in 3D reality. It's more realistic to see how it looks like. And the industry it changes a lot of things because now there's a physical object which is built by hand and you can learn more about it in the virtual world, give you more additional information about it. So with the applications, it's fast, and with this particular technology, it doesn't just rely on like a special glasses. It uses a combination of already existing technology like cameras on our mobile phones and also other hardwares that are designed purposely for this application. So some of the applications are quite interesting. In archaeology, it changes so much. Because, for example, during the Romanic ages, where they had these Greek temples all over the place, and the Romans destroyed all the Greek temples and the civilization that lived before us, it's very difficult to describe to someone. But if you're able to visualize it, it gives you a different perspective of how the people lived. So you go to a ruins in, let's say, Italy with like a giant Greek temple, which is just left in rubble, so degraded because of harsh weather conditions. You're able to reconstruct the entire thing to make you have a sense of how things existed before the ruins, so like the whole thing was damaged. And in the industrial applications, there are a lot, especially in the assembly lines. People are able to read details about parts and pieces from these glasses. So the properties of the object is projected immediately touch the object. So for example, you have um, uh, a bolt or something not somewhere, and you're able to know more about what the bolt does in relation to the production line. And for entertainment, as you can see for here, we use it a lot. Or it was very popular when the Pokemon Go became a thing in New York. People were just walking around collecting these Pokemon chips and cards and engaging in fights. So you see someone on the subway just projecting their phone and shaking them vigorously because they're interacting with the virtual world on their cameras or on their phones, which was very interesting. And in the art scene, it's becoming more and more interesting because Sometimes you go to a gallery and there are pictures and there's not much context behind the picture. But with the VR, you're able to reproject the art and perceive it in a 3D shape, looking at all the details zooming in and out. And it changed how we react with art and even music and gaming. It changes a lot. In the fitness studio, in the fitness industry, they've also adapted it where you can project some of the movement of exercises. So, for example, if you want to do a cha-cha dance and you've never done it before or done salsa before, for example, you can project the steps in your way and give you like a one-to-one tutorials in real life without necessarily having a coach next to you. And in commerce, it's amazing how it's being used in commerce, because in commerce, most people are indecisive when it comes to buying things, and I guess most of us are guilty of it. So if you're able to perceive the thing not just on the image, but rotate it, check how the sole of the shoe looks like, how the couch will fit your room, how the curtains will look in your living room, it changes how you interact with the product. And I know some gender will be guilty of this. When we go to shopping for dresses, we take hours trying everything on. But if you can just wear virtually the object on yourself and walk around and see how it feels, of course, it's not going to feel the same as implemented, but at least you have a feel of how it would snap onto your body, or like how the coat looks on you, for example. And it will save a lot of time, if I may ask, if I may say, sorry, it will save us a lot of time when it comes to commerce. So enough talking about the general stuff. I'm going to talk about two cases when it comes to engineering, because an engineering is relatively new, because all the engineers around the world admit that we are also very hesitant to adapt new technologies because we trust our calculations. So you have engineers who are still living in the calculator ages, where they would personally take calculators and punch out numbers and refuse to use computers. So it's taking us a very long time to come here. People still want to read. There's nothing wrong with reading a hard copy map, digital maps, but it has a lot of limitations due to, like, I don't know, getting wet in the rain or being distorted. So as engineers, we sometimes hesitant to adapt to technology. So I'm just going to talk about a few two use cases of how these things are being used in the industry by two companies, two giants in the space, and we'll see how it plays out. So this is a short, let's see. Yeah. So this is a YouTube video of how it's being used in design and of architectural buildings. So in engineering, you draw most of the time in an AutoCAD space, and it's very difficult to perceive 3D if you're not present on it, especially when it comes to scale. But this one, it gives you a sense of, so this one currently the architect is moving the sun and see how the shadow will be cast on the object over time. And he's interacting with it in real life. And he can switch between the, so I'll pause briefly. I think I would, um, yeah. So here he's switching between the design model and the X-ray. So the X-ray is all the things that exist underneath the wall. So the pipes, the tubes and everything, he's designing them in real time, or like in using virtual reality. He can walk around, inspect the pipes, inspect the tubes or channels. And I don't know all the civil words, but I guess I'm right. The electrical constructions, the water insulations and stuff like that. So it changes how we even understand our designs. Most of the time you draw with a huge scale or a smaller scale, and it's very difficult to perceive how it would look like in a real object. So with this particular application or this particular program, you're able to not just visualize the exterior, but you can also see what's happening underneath walls or behind the stuff, and you can also look at the mechanical components of also the design. So it gives you room to actually manipulate and walk through with a higher level. So I'll quickly pause and talk more about how these things work. So you have your CAD model, which I think most of the engineers would be familiar with, or non-engineers. It's just a computer design, um, computer aided design. Then you load it into this environment, then into the virtual reality environment. You put on your glasses or your hardware, and it gives you the room to navigate this space, looking at all the flaws you did or like where it's inefficient, you can in real time correct it. So it gives you more of a leverage or a good control of how that real object, if it's built, will look like. Bear in mind, the conceptual model is, or like the design model is never the same as the as-built model. But if you're able to live the design model in a virtual space, it gives you a very good sense of what could be possible and what couldn't be possible. Because I think usually designers or like architects are so detached from engineers that they can design stuff that are not really feasible. But if you make them walk through the design with you as a structural engineer or a civil engineer, you walk through the design with them and show them certain things that are not possible, humanly possible, like engineering inefficient. It can help minimize the cost of rebuilding, this like destroying stuff and redesigning and adaptations that are not necessary. So with this particular technology, especially the designing part, it changes a lot. And for the geospatial people, if you're interested in building intelligence modeling, it helps so much because you have all the information about the objects, the material, the texture, the durability, the duration, and all those things in the virtual space. For example, the as you can see from the shot here, uh, these are how they call it, entry scanners, and usually if you're designing something, you give to an architect, give something like this to you, it's just like a two line or a dash or something. If it's a 3D model, you can't really explode it and see the content of it. But with this particular one, it shows you how it even opens, what the mechanics looks like, and all those things are labeled into detail. So it makes it more immersive to walk around in the space. It gives you a good sense of what you're doing before you even start the project. So if all projects, for example, in road construction, is virtualized and placed on a good, approximately fair terrain, you know how much cut. I'm trying to use my engineering a bit, been a while. Some what's it convex for? The cut and the fill thing, I've forgotten it. So how much you should cut, how much you should fill, how the gutter should look like, whether it should be an open gutter, it should be a closed gutter, for example. So it gives you a very good sense of what it is. And it really enhances how you perceive the space, how you walk through walls, how it should look like, and it changes a lot. I experienced it, and it's really interesting. For example, dimensions. A lot of people struggle with dimensions, um, no calculation of dimensions, and it can help. For example, as you can see in the video, you can get precisely how the room will look like. Of course, the design model, as I keep repeating, the design model and the as-built model is not the same, but at least it gives you a sense of how big the room is going to be if you have to make some adjustment. There's always a very popular case where they were designing two bridges and the built on from the two ends of the bridge, and it got to the middle and it couldn't fuse because the surveyors and people couldn't do the measurement correctly. But if you're able to simulate everything properly in the virtual world and even simulate how the building will be constructed, you can avoid all these things in the design process to avoid any humiliation of that sort. Right. So we go to the next case study, and this is more close to home, I guess. At least if I understand what your company does. So, yeah. So let me move this out there. I was just again. So in this particular project, they are trying to use virtual reality to show where the pipes are underneath the road. So most of the time, especially structural engineers or like even road construction, it's so difficult, especially in Ghana, to notice where pipes are, the depth, the 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 width of the pipe. So if you want to reconstruct a road or lay some new channels around it, we end up cutting through a lot of optical fiber cables or like stuff that are not supposed to be destroyed because we are not able to visualize how the structure looks underneath the road. So with augmented reality, so the first one is virtual reality where we're simulating the whole environment in a box. But with augmented reality, we're projecting what exists under the road onto the road surface for precisely digging, precisely cutting of lines or stuff like that, so that we can minimize waste and also the cost of operation most of the time. So this is a showing the depth of for example, there's the civil engineers will kill me. I think this is the cover for a drain. I think that's how it's said in civil engineering. A drain cover. I guess you get a picture of what I'm trying to say. So with this particular one, it shows you the dimension of it, the depth of it, which is something you can visually see if you walk along the road or walk on top of the road. So with the augmented reality, adds additional information that you can never get if you sit in your office or you just walk over the space. And this changes how we relate to construction or we relate to design and so for example, in this intersection, let me go back a bit and see. Yeah, I know. Yeah, yeah. So on an intersection, which is one of the complex things for most civil engineers, it's very difficult to know what is going underneath where, and it really changes your reaction with the environment if you could see things that are underneath it. And it really helps to, as I always mention, minimize the cost and distraction and also working time. So if you have to take your time and trace by foot, I think that is what most of us do. So we go to look for the pipe and we walk, we assume it's going a straight line. We just walk the line until we hope to find another connection point or like a network. And it takes so much time. But with augmented reality, it's projected. So you're able to see exactly where everything is going. You can eliminate all errors and minimize time wasted, which is a big thing when it comes to engineering, because efficiency is all about maximizing the time you have. Yeah. So this is the hardware they are using to, it's connected to a GNSS to give it more accurate positioning. And they just carry that. It's a very simple hardware. It uses his phone, scan the space, then automatically it generates or it projects the design or whatever thing that is in the 3D space onto the real world. And you're able to perceive all the pipes, the diameter of the pipes, how the connections look like, where they are going to, the number of people accessing them, stuff like that. And because it's not distracting your reality, you can still have people working in the background, for example, and you can still have the road there. And I think that's for engineering, especially if your work involves field work, this changes so much how you understand. So, for example, he navigated exactly precisely to where the cup is, and he can see all those things projected from the virtual space onto the real space. And I think it helps so much with designing, redesigning, maintenance, and it really changes how we apply technology in solving very simple problems. So with these use cases, we would ask more questions about it. We can talk after the presentation. You have questions about it, and I can dive a bit deeper into it. Now we look at the future possibilities. What can we do with this technology? I've been talking about technology, but what are the potential of this technology? Bear in mind hardware and the software integration, and also the use case for your space. So the current trend or the current use cases for especially my industry where I work, it's for structure maintenance and structure health monitoring. So most of the time, as I mentioned several times, the as-built model is usually different from the design model. So to ascertain the differences between what was designed and what was built, it's always good to have the design model projected onto the as-built model so they can visibly see the differences between what the architect or the structural engineer said as against what their construction company built. And so it makes inspections very fast. It makes them, you know, where there could be faults and flaws in the design or flaws in the structure easily. And it's accelerates reporting when it comes to deformation or destruction. And you can easily see design errors. You can easily see add-ons that didn't exist, and it can be probably explained by the construction company why they add an extra layer of asphalt or concrete to this particular space. So it makes the work slightly easy, in my opinion. Okay, and also when it comes to collaborative design, it changes it because what's very painful is usually the architect is sitting in one company, the structural engineer sits somewhere else, and they are both designing the same structure. And by the time they present the documents, they are not matching. So they have to spend hours and hours again correcting here, changing dimensions there. But if we are able to immerse ourselves into the same space, working on the same project, you bring the object, I ask you why you're putting it there, maybe structurally not safe or structurally not sound. It's more interactive. And for clients, it's more interesting for a client to be able to walk over his property and have a feel of what he's paying for looks like. And I think it will probably make people pay their money faster. Hopefully. I hope so. And when it comes to manufacturing too, it really changes so much. I was making this joke that if it gets to a very large scale, we might not need mechanical engineers because you open the bonnet of your car, you know what to twist, what to change, what to remove, and a group of people will be very happy because they don't have to go to the mechanic every 2 weeks to fix their brake parts, for example. Because as you can see from this image, you can see what a one brake part looks like and what an ever one looks like. They just buy the part, gives you the step-by-step tutorial of how to replace the parts, and you're good to go. So it would really change how we manufacture things, manufacturing lines look like, how we replace or do maintenance on our own vehicle, personal vehicles or personal stuff. And when it comes to training, it changes it so much. For architects or engineers, it takes you some time to work with 3D objects, um, which is mostly the case because most people are used to 2D sketches. So we can easily understand 2D sketches, but when it comes to 3D space, in as much as we live in a 3D environment, engineers are very reluctant, myself inclusive, to appreciate the 3D world. So which if you're able to create a virtual thing and make them actually train themselves on it, it can help make us think in 3D and not in two dimension. Because I know for a fact that structural engineers do all their the force computations in 2D, which for me is always ridiculous. I'm sorry if you're a structural engineer, but for me it's a very difficult thing to perceive because you build a thing in 3D. So if you're computing, doing all your computations in 2D and doesn't really translate properly into 3D. But if you're able to learn and train ourselves in doing all these computations in the 3D space, it makes it so easy for the people constructing, the people perceive, like realizing the virtual design into like an object. It makes it easy for them to also appreciate some of these things. So when it comes to training, to really change so much design and structural maintenance, for example, all these things will really be improved if you're able to adapt the technology to fit these guys. Um, every technology has its own flaws. So this bit is what might not be a bit interesting for some people because the cost of the technology is still high. Apple released their Mac Vision Pro, and the first iteration cost about $4,000. And I'm trying to see the Ghana city equivalent. That'll be like 45,000 Ghana city. I mean, for a big company like yours, I'm sure you can buy 5 of them. But for most industries, it's very difficult to buy the hardware, let alone the software. So the cost of integrating some of these things into your process chain is quite difficult because of the initial cost, and also like the prolonged use of the technology can really mess up your health. So as I defined in the previous slides, virtual reality, augmented reality is just tinkling with your senses. So your vision, your ear, your hearing, sorry, your hearing, your smell, your touch. And if you wear it for a very prolonged time, you lose sense of the real world. Or like it could create this delusive world in which people get easily lost in the virtual space. So if you live for a long time, it can mess up how your brain functions because our brain is used to interacting with the real world. So people who are like, especially gamers who live 3, 4 hours in the virtual space, they come out and they can spiral into depression or other things that are not beneficial to your health. And for especially engineering, most of the software we use for um, augmented and virtual reality are all in the experimental phase. So as a research scientist, that's what I basically do, try to come up with more experimental software and applications of how some of these things will be used. And so for now, even if you want to do it on a commercial scale, it's quite expensive to convert the experimental software into something more productive that you can use. And myself inclusive, as engineers, we take forever to accept new technologies and adapt to them. I know people who are still drawing on papers because they don't want to use CAD model and it's for the kids. So it takes us so long to integrate some of these things to our pipeline or our daily use. It takes us forever. And it's also because there's lack of education when it comes to the benefits of it. So most people just see the downside. I mean, I'm sure most people here just knew VR in the perspective of gaming. So if you've known it from just the gaming world, it's very difficult to take it serious if you say you want to use it in an industrial case. A lot of people might not value it until they know the use of it. And I think the last thing, which is a bit problematic in where we come from, is connectivity. All these things will work perfectly if we have a stable, reliable internet connection. So with that infrastructure not in place, it doesn't really make entire sense to go all in on it because there's an interaction of the hardware and the internet, the software with the internet to be able to maximize the use of this. And in the Western world, with the 5G implementation, it really changes a lot. But in Ghana, or where we come from, it's very difficult to have a very stable internet connectivity for long hours. And as you can see, it can also make the old people a bit scared because it changes. I'm not very old, so I can make fun of them. It makes it very difficult to decipher some of these things because the technology, and I sometimes don't blame them because the technology has moved too fast from people not believing that we can put phones in our pockets to wearing technologies on your face and living in a different world. Well, so you can scare people off easily. But all these things are things that come with any new technology. The same with mobile phones evolution and how it took some time and all the problems that came along with it. But I think in looking into the future, it looks more promising because some of these challenges are solvable. For example, the internet connectivity. I'm just hoping we get to a day where we can use a consistent 4G or 5G connection to take full advantages of the technologies that exist. And that brings me to the end of my presentation, so I'm open for questions.
Thank you, Kwasi, so much for a very insightful presentation. seeing how the technology is evolving very quickly and even realizing that it took shape in 1938. It's even more exciting for me realizing all this today. Like our presenter said, we are opening the floor for questions now. So if you have any, can raise your hand like we usually do, and then you'll be able to attend to. Whilst I wait for the questions, you mentioned a number of challenges when it comes to the adoption of the technology. But in spite of this, do you think it's still scalable? It's something that is scalable and can be used across the diverse industries that we have.
So I can only speak for what I have experienced so far. So currently the Deutsche Bahn, the train system in Germany is using it excessively to inspect all their bridges. So for bridge inspection, they're trying to use augmented reality and virtual reality to mostly augmented reality to capture where the faults are and look at what lies underneath the bridge. So when it comes to scalability, it's possible on a large scale. For example, in Bosch, one of the famous engineering, mechanical engineering companies, they use it also on their production chain. So it's scalable. It's really highly dependent on like it's emphasis on highly dependent on the sort of production or like the sort of service you render. So when it comes to inline production where everything is in one big warehouse, it's easy to integrate some of these things. But if your service involves you moving around from one location to a different location, which I think when it comes to road construction, then civil engineering, that is the case. I've not seen so many companies use it. I think apart from VR Collab, which sells the software, that's why they are mostly using it on different projects. I don't see it in large scales. I mean, people are using it in smaller scales from here and in different spaces. But for a big company, I think VGIS is trying to use it in the US for public road maintenance. I think in Atlanta, I think I also saw a couple of them being used there, but scalability, it's yeah, it's a problem right now. It depends on like it's now used by very small companies, and I don't know big companies that are using it. To be fair, I don't know a lot of big civil engineering companies, so that's also not a good reference.
That's fine. That's fine. So we have a question from engineer Emmanuel Banfo, who is a GIS specialist. I think his question is geared towards that. He says, good morning and thanks for the insightful presentation. He wants to know what are some of the softwares that you would recommend, especially for engineering simulations, that is walking your stakeholders through design models.
I think the first I'll start with would be Rivet is quite easy to use, and I think it's easily used by also the architects and also the civil engineer. Adobe Autodesk Rivet, I think that's the name. Because I'm on the research part, we develop our own software, so I build my own ones. But for commercial ones, I think Rivet gives more room for people to walk around in 3D space. And also VR Collab has a couple of softwares that you can use to load in CAD models and gives the client a chance to perceive your designs or perceive your work in a walkthrough experience. So I think that those are the two I recommend. So Autodesk Rivet and also VR Collab. Those are the two softwares I recommend for now.
Okay, thank you very much. So the floor is still open for questions. If you have any, the presenter will be able to attend to you. Okay. So I'm forced to believe that you gave us such an exhaustive presentation that most of our questions were answered. So I'll take kudos for that then.
Thank you. I
Yes,
realized you could barely see my face because of the position I'm sitting. I think my
yeah,
background is
that's fine.
on
Yes,
my side.
I think it's fine. We can work around that. So I think it's safe to wrap up the session since we don't have any more questions. I'll say thank you very much, Kwasi Nyarko, for making the time to join us. When we called on you, you wholeheartedly accepted, and it's been exciting listening to you this morning for unveiling the information and the influence that augmented and virtual reality is having in the infrastructure sector, the insights you've shared, the case studies, the discussions on design impacts and the collaboration, all of that has actually left me very inspired. I can't wait to see what more comes out of this technology. As we wrap up, I'll say to everyone who joined that let's carry forward the possibilities and insights that we've gained today, and also say thank you for actively participating, listening to this concise and yet very enlightening session of our K&E series. Thank you once again, and I wish us all a very fruitful week.
Thank you.
Thank you. Hopefully we should have you on again. All right, okay. Do enjoy the rest of your day.
Enjoy your day as well.
Okay, bye.
Bye.